Okay, so for this third demonstration, I'm going to use a different ground control station in a Windows-based computer. So I'm starting up the drone and the drone VM just as before. Even though I've got, I'm going to use my actual Windows machine that I'm running the VirtualBox in. Yeah, you can see I pull up here and that my IP address for this machine is 192.168.65.141. So I'm going to use that to set up the drone to listen for that IP address, just like I did before with the VM based ground control station in the last video. And I'm going to go ahead and run Mission Planner. So Mission Planner again is a different ground control software, much more graphical type stuff, and much easier to build waypoints and things like that in than the MAV proxy. But it only runs in Windows, so not great for running in a VM, since I don't have a lot of Windows licenses to just throw at VMs. Okay, so it's connected and it's loading the information from the drone firmware, which is being simulated in the drone VM, and again using ArduPilot as the firmware OS, and kinematics are being provided by JSBSim, just as before. I'm going to use the local commands in the drone just to get the drone started and up at altitude, just because I'm more familiar with the MAV proxy software. But you can see everything I'm doing is also being reflected on the Mission Planner. As you can see here, the drone is climbing to the initial altitude of 40 feet that I gave it. And then from here on out, I'm just going to use the Mission Planner software to control the drone. I just haven't configured it yet for all the startup sequences and stuff for the drone. So it was easier for me to start that off in the MAV proxy, and then just switch over to the Mission Planner. All right, so I'm going to give it a waypoint to go to and an altitude. You can see the quadcopter responds, starts heading that direction, banks a little bit to get there. As before, I'm using a Wi-Fi, actual Wi-Fi network. So I've got my computer's internal Wi-Fi adapter on that 141, and then I've got a USB Wi-Fi adapter that I'm using that's being passed through to the drone VM on 5.4 is I think what the drone's set up. And these are being connected via a portable router. So the signal is actually going out from my machine via its internal Wi-Fi to the router, being routed back to the other adapter, which is physically plugged into my machine but is interfacing with the VM, being passed that way. So the latency again is what you would expect for if I was flying a drone with a computer with the same distance between to the router that I have now. Of course, that'd be an ad hoc network rather than a routed network, and I could have set it up to do that just the same. It's just without wanting to lose my internet connection every time. It was easy enough to demonstrate it, but it's the same UDP over IP protocols that we're using to pass stuff over the 2.4 gigahertz Wi-Fi signal. As I said, ultimately I'd like to try to get the TCP/IP connections working, but even with the UDP protocol, we can still use a remote ground control station from almost any distance, anywhere, as long as it's got a connection to the internet to pass those UDP packets to the drone VM once we get that up on in the cloud. So again, I'm just demonstrating different commands, changing altitudes, changing different waypoints. Excuse me, destination points. And you see how the drone responds to that. You can see how the console also is reflecting, the console in the VM, the drone VM is also reflecting all the stuff that the drone is doing. So I'm going to go ahead here and issue the return to launch point command, so you can see the drone swinging around. One of the nice things about the mission planner is you can see it's got points to waypoints. I did set up some waypoints, but I didn't get them in the same geographic location as the little Australian airport here that we used for all these demonstrations. But that orange goes all the way out to where the next waypoint is, and the black line is the actual heading of the drone. So you can get a lot more data out of this. You could also set these up, either of the MAV proxy or even a lot more with the mission simulator to record a lot of data. You can see altitude changes and plot a different bunch of graphs about all the stuff the drone did. And you could use the drone, if I had the equipment on there, to model, to take 3D models of the stuff that was flying over. We could see all that and do all that. So again, with a combination of a ground control system, that ArduPilot software simulating the drone OS, and the JSBSim to provide the kinematics, and with this nice Google Maps, we can really simulate all the things that the physical drone would do. The major exceptions are obviously the VM is not running on an Arduino. So it's got considerably more memory and graphics processing capability and just raw processor power than the actual drone would. So that one of my next challenges is try to get that drone VM down to something much smaller, like a Raspberry Pi OS, but that would have to be emulated since I don't have an actual ARM processor that I can run in a VirtualBox. So that's one of the next challenges. But either way, I mean, really what we're trying to simulate is, again, the communications and actions and response of the drone. We can simulate all those failure modes. What if it loses comms? What if it loses its Wi-Fi connection? What if it loses its GPS signal? All those failure modes to see how the drone will respond. So this will be perfect for our project, where we have the red team trying to disrupt the drone and the blue team trying to make the drone more resilient. And you see it landed back at its origin port and shut down just as before.